Welcome back. In this lecture, we tackle a classic multithreading problem that demonstrates why uncontrolled concurrency can be disastrous. The ticket booking use case. We will simulate two users simultaneously trying to book the last available ticket. 1. The shared resource and task. We define a global variable, available ticket, and initialize it to 1, representing the last ticket. Our book ticket function represents a user trying to book. The critical part of this transaction involves two sequential steps. First, checking if tickets are available, and second, decrementing the count if they are. The problem arises if two threads execute the first step before either one can execute the second. 2. Creating the race condition. Inside the if condition, we simulate a small delay using time.sleep parenthesis. This pause is the key. While the first thread, say, user 1, pauses after checking that available tickets is greater than 0, the operating system may switch execution to the second thread, user 2. User 2 also sees that the ticket count is 1, enters the if block, and pauses. When both threads eventually finish their pauses, they both successfully decrement the ticket count, resulting in a negative number which is logically impossible. This is known as a race condition. 3. Launching the competing threads. We launch two threads, user-1 and user-2, and then wait for them to finish with .join parenthesis. When you run this code, you may consistently see an incorrect final ticket count, likely -1, even though only one ticket was available. This severe bug in shared data integrity is precisely why we need the next topic, thread synchronization. To summarize, the ticket booking problem proves that sharing data between threads without strict control is unsafe. Our next lecture 26.10, Thread Synchronization. See you there.